Hi guys, it's still Mr. My Money again. Foot. Welcome to Simplified RSA, the guys who makes it looks easy. Today, well, we're still continuing with quadratic functions, but then here's some important stuff I need you to understand. So f of x is equals to ax squared plus bx. Like we said, this is the standard form of a quadratic function. Now, the vertex form of f of x, it looks something like this. It looks something like this. F of x is equals to x is equals to a into x minus h, that thing squared, and then you have plus q. That's when we'll say our vertex is h and q. So vertex is the point. Another name for a vertex is turning point. So it's a turning point of a parabola. Is h and q, which is determined by this value and this value. H and q is your vertex. So now, the third property of a quadratic function, which is a parabola graph, is the turning point. Now, we know that the turning point, sometimes the u is facing up, sometimes the u is facing like down like this. So it's either concave up or concave down. What determines if your graph will be concave up or concave down is the value of a here. So A determines if you're going to have a minimum vertex or a maximum vertex. Remember, vertex is the turning point. It's where the graph turns. So ideally, if we have our graph there, the turning point, the graph would go something like this if you have seen the parabola graph or the quadratic function. So this point here is said to be our vertex, which is the turning point, which is determined by this point, right? And another thing I want to add there before I go further. Another thing I want to add before I go further is just to remember that a point mathematically is represented by x and y. This is how we represent a point in a Cartesian plane. Meaning, if you have 2 and a 3, we automatically know that the 2 is the x and the y will be the 3. Meaning here, the h and the q, we expect the h and the q to be in the form of a number somehow. However, the quadratic function in most cases will be given in the form of the standard form. It's your responsibility to derive the standard form of the quadratic equation to become the vertex form. That's how we can get our turning point. After this video, I'll show you further different ways to can get this turning point thing or the vertex. But then for now, I just want to show you to move from the standard form to the vertex form. So the only way you can move from standard form to the vertex form of a quadratic function is to complete a square. I already made a video where I introduced how to complete the square, but the difference is at that case, there was an equal sign. Here, we have to complete the square while we're maintaining the value of a. So instead of dividing by a, let me show you. So I'm going to complete the square to move from here to here, meaning I'll complete the square from this one to obtain this, right? I'll complete the square from this to obtain this. Let's go. Let's do it together. So as discussed in the previous video, the first thing that I'm going to do here is to divide by a throughout this. But then the a this time around, because it's f of x, like I said, this is the same as y. I don't have to take the a anyway. I can just put it aside there. So here, if I divide by a, I'll have x squared plus b over ax plus c over a, just like that. Remember, I have to complete the square to move from standard form to the vertex form of the equation. So completing a square means I must add and subtract half the square of the coefficient of x. And I said to get half of this, you just multiply it by half. So b over a times half is going to be b times 1 is b over 2a. And then I must add and subtract the square of this. Let's do that. We are completing a square now. So the next step will be a is to x squared plus b over ax. And then I add the square of the coefficient of x, b over 2a squared and then I subtract it again, b over 2a squared. So adding it and subtracting it, it means like I just added 0. There's nothing much is done there, but it's just a mathematical procedure all over c over a. So that's completing a square. Moving forward here, I will have a is 2. Now, remember how to factorize the completing of the square? This is how I do it. I take the x only. I take the sign of the coefficient of x plus, and then I take only what is inside the square to be b over 2a, because the square, this square and this square will come here because I'm factorizing this part here. Therefore, this is going to be minus b squared minus 4a squared plus c over a, right? Now, remember I have an a outside, or let me just put that like that. Remember, I have an a outside these brackets. Now, I want to bring back the a inside here. So when I multiply back by a everything, I'll have a into x plus b over 2a squared, because a times this. A times, okay, I just want to arrange this in order. I will say a times c over a. This is going to be plus. I just want to bring this one to the positive side. So it's going to be c over a times a times a. This will cancel that. Therefore, it's just going to be c. So c over a times a just going to be c minus, if I bring the a times b squared over 4a. So it's like this, a times b squared over 4a squared. A goes once here, a goes twice here. So we're going to have b squared over 4a if we multiply a by b squared over 4a squared. So meaning this part here will be b squared over 4a. Yes, that's it. So from this, we can see that now this is in the form of f of x is equals to a x minus h squared plus q. So the difference here is just that h is b over 2a, and then q is c minus b squared over 4a. You can see that these things are similar. Meaning here, minus h is equals to b over 2a. It means our h will be minus b over 2a. So the value of h, this h here, the value of h is represented by b squared over 2a here. And then q will be c minus b squared over 4a. So meaning here, to get the vertex, the very same C, B, and A, the very same B and A that we see here is original from A squared plus BX plus C. So whatever value you have on C, it's going to be the value that you have there. For B, it will be the value for B and for A. So I said the vertex is given by HQ as a point, right? Meaning to get H, you can just say H is equals to minus B over 2A. And then to get Q, you can just say Q is equals to C minus B squared over 4A, given that you have the values of your quadratic function. So now we can see that this is just the skeletal way of doing the things. Let's get the proper quadratic functions and see how the application will be. Now here we have the standard form of a quadratic function in terms of numbers. We know that the story is I will let x to be 0 to get the y-intercept. I will let f of x to be 0 to get the x-intercept. That's the whole story. But then for now, we want to find the turning point, which is the vertex. Meaning now I have to write this standard form into the vertex form. I must write this in terms of this form. So meaning now I must write this in terms of this. That means I have to do what? I have to complete the square. Now, let's complete the square on this one. So I will divide by 2 throughout here. I will take 2 out as a common factor. Therefore, I'll have x squared here minus 4 divided by 2 is minus 2x minus 8 divided by 2 is minus 4 because I took 2 out as a common factor. The reason being I want to complete a square in order to put the standard form of the quadratic formula into the vertex form. Therefore, this is going to be 2 is to x squared minus 2x. Now, to complete the square, I will add and subtract half the square of this. Half of 2 is 1. The square of 1 is just 1 squared. So I'm going to add 1 squared and I subtract 1 squared again because that's completing a square, and then I subtract the given 4 as it is. So this 4 is there, 2x minus 2x is there, x squared, and then to complete the square, I added and subtracted half the square of the coefficient of x. So therefore, going forward, this is going to be, now to complete the square again, I'm just going to take this as x, and then I take the 1 that is inside the square. I don't include the square, just the variable inside, just the number inside the square. But the sign, I take the sign of the coefficient of x. So it's going to be minus, since it's a negative, this 1 here, and then I bring the 1 here, I close the bracket. Therefore, this square, we put it outside because it represents factorizing this entire thing here. Meaning, if you simplify this, you'll get back to the way this thing was. Therefore, this part, we can just simplify this. We have minus 1 squared is 1 minus 4. Just like that. Therefore, this is the same as 2. I have x minus 1 squared. I just want to simplify this part. Minus 1 minus 4 is minus 5. Minus 1 minus 4 is minus 5. The next step now is just to multiply by 2 with what is inside. I must multiply 2 with what is inside. So this is going to be 2x minus 1 squared minus 10. So now this is in the form of the vertex. We can tell that f of x gave us the final value of this. Now it's in the form of f of x is equals to x minus h plus q. Here the sign is negative, here the sign is negative. So meaning if we want to take the turning point out, it means our turning point, which is the vertex, is 1. If it's a negative, we take it out as 1 and minus 10. Let me just write it clear. I'm saying our vertex, which is the turning point here, is positive 1 and minus 10, like that, which is our vertex. Otherwise, if it was a plus here, our turning point would have been negative 1 and negative 10. So if you take it out, it has to oppose the sign of what you have when it's in its vertex form for the x value. So if it's a negative, it becomes a plus. If it's a positive, it becomes a minus. But then for now, to conclude, our vertex, which is the turning point of the graph, our vertex is 1 and minus 10 for this one, because we've moved from the standard form and we've placed it into the vertex form using completing a square, right? Okay, fine. Now that's just one way to find the vertex, by completing a square. Alternatively, if you have studied, you know that if you complete the square from the standard vertex form, like from the standard form of a quadratic function to the vertex form, you already know that h is equals to minus b over 2a. H is equals to minus b over 2a. And according to this, okay, sharp, talk is cheap. Let's put it like this. If we have this, we know that the standard form should be f of x is equals to a x minus h squared plus q, right? And I did say h is equals to minus B over 2A, and Q is equals to C minus B squared over 4A. Because we know that our vertex should be somehow H and Q. So to get the vertex, the value of H, you can get it by just using this formula, minus B over 2A from this. And then the value of Q, you can just say C minus B squared over 4A. How so? From here, we know that A is 2. Here, our A is 2. B is minus 4. Our B is minus 4. And then C is minus 8. Our C is minus 8, right? So just by substituting this, we have to get the same value as when we completed a square. So H is going to be minus B minus 4. So B is minus 4. So the equation comes with a negative. So it's minus 4 all over 2. A is 2. Therefore, this is going to be 4 over 4, which is indeed 1. Meaning here, our vertex for the H value, we get 1. What about the Q? Let's get the Q here. The Q is equals to C is minus 8. I take it as it is minus 8 minus B is minus 4 minus 4 squared all over 4. A is 2. This is going to be, you can just simplify this from your calculator, but then it's going to be minus 8 and then 4 squared, minus 4 squared is 16. So it's going to be minus 16 all over 8 like that. If you simplify this further on your calculator, you'll get that this is the same as minus 10. But then you can just prove that, because I don't have time to can do step-by-step of fractions. I believe now whoever who's watching these videos, adding and subtracting fractions shouldn't be a problem. But if you're still struggling from adding and subtracting fractions, you can just look for a video on our list, on our playlist. You can see if you can find a video where we're showing you how to add and subtract fractions. But then this is going to be minus 10. So this is going to be minus 10. So if you don't want to complete the square, or if you know completing a square is actually hard for you, to get the values of the vertex in terms of H and Q, you just know from the formula, it's like that. But they just have to remember that H is equals to minus B over 2A and Q is equals to C minus B squared over 4A. So these two things that are so important to get your turning point. So the punchline of this lesson is just to understand the vertex, which is the turning point of a quadratic equation. How to get the turning point, or rather how to get the vertex. How to move from standard form of the quadratic functions to a vertex form of quadratic function. That helps you to get your turning point. So this is how it's done. On our next video, I want us to check or discuss the nature of a quadratic function. If it's going to be concave up or concave down. If the nature of the vertex is the vertex going to be a minimum or a maximum. Join me on the next video as we continue about stuff like that. For now, we can stop from here. I'm Mr. Money. This is Simplified RSA, the guys who makes it look easy. Please remember to subscribe to our YouTube channel. Follow us on X, follow us on Facebook, follow us on Instagram, as well as on TikTok. Also, you can find our learning channel on Spotify. So when you go to Spotify, you can search for learning channel, or you can, like, 2 words, learning channel, or you can just search simplify_RSA, simplified_RSA. I'm done for today.